Hello, I'm Qing. Today I'm going to give an introduction about PPNID, which is a program that I developed for identification of plant-parasitic nematode. First, why I developed this program? For majority of researchers who want to identify nematode, what they do, usually they copy and paste their sequence and into a BLAST. Then they get a long list of different matching values. As you can see here, and to identify species, just pick up the one with the highest match value, like this one, with 100% matching. But we cannot rely on BLAST. Of course, we can use it to have a brief idea, but we cannot rely on. We cannot only use BLAST for species identification for nematode. It may work for fungi, for bacteria, but it's not working for nematode. Why? There are many reasons. For example, there's a lot of error or mistakes in the database of a gene bank. The first one here is a heterodactyl. This is supposed to be a cyst nematode, which is a famous plant parasitic nematode. But actually, the sequence here is just a fungus, belong to the genus Malassea. Also here, you will find a lot of sequence end with sp dot, but actually they already have a name. Also, there's many sequences which are not properly assembled or trimmed. All of these can cause errors or problems for your identification result. The second reason is most important reason. For many species, you cannot identify them in BLAST at all. So here is an example of Melodygani. This is a genus. We usually call it root knot nematode. This group of nematodes are usually very similar in genetics. So if you use 28S, 18S, or ribosome genes to blast them, usually you get 100% matching for several different species. So you don't know which one is your input sequence. Okay, because of this reason, I made this program. So now I'm going to show you how to use this program. First, you can go to our paper. Then there is a link here. You can open this link and download the latest version. There may be several different versions, but make sure you're using the latest version. Okay. If you download, you will find something here. Then double click. Okay, this is how the program looks like. Basically, there's 4 parts. In majority cases, we use standard identification. So I click here. Here is the example of 28S sequence belong to Dolichodoridae. So I select Dolichodoridae and it's 28S. Okay, in most cases, I believe you know what you're doing, which gene you amplified by PCR, and the brief idea which group, I mean the family level of nematodes, which group you're using or sequencing. But in case you don't know, go to BLAST and to have a brief idea. And here, if you don't know how to amplify which parameter you need to use, you can click help. It tells you which genes, which parameters that you can use. Okay, so I submit this sequence and it comes to the alignment. So you don't need to do anything. The program will do alignment for you. Here is the result of alignment. In the left column, you see a lot of species that has been used to compare in the database. It contains a lot of information, but it's hard to interpret. So I click here and the program helps me to do the automatic species identification. In the top of this small window is the highest match of my input sequence. In this case, it's a Telenchorhynchus agri, and you can see here there's 4 different nucleotides differences, and the second one has 27, and the third one has 40. So this one, the first one, has the highest match, but we cannot say the first one is the species that we input because there's no specific border. Like if it's 99% similar, we can say it's same species, or if it's 97%, it's same species. In nematode, there's no specific threshold like this. So it's a matter of how many percent, how you interpret. This stage usually causes some problems. So because of this reason, we don't want to have too much objective decision. So I develop a method that helps you make a more or better decision. How it works? So it gives you a graph, a plot. So you can see the red dots. If the red dot is in the first block, usually your input sequence is very likely to be the same with the highest match. In our case, red dot is in the first block. So our input sequence is very likely to be the Telenchorhynchus agri. However, sometimes the red dots will go to the top block. This means either your sequence is a new one, it's a new species, or your sequence doesn't have any sequence in the database. So in this case, you cannot say the highest match is your input sequence. The middle one means your sequence has some quite high similarity, but still quite some differences. So we can say the highest match is your input, but without any confidence. So for more detail about this method and how to interpret, you can go to our papers. Okay, so from this graph, we have a little bit more idea. And once more, we have more method to interpret this data. Just click build a phylogenetic tree, then it pop out a window to tell you it takes quite some time to make a tree. Then just click OK. Then the program start to make this tree. This process usually take longer time, depends on your database, how big is your database, and how long is your sequence. So we will just wait here. Okay, the train's finished. So just click draw. Then we have a phylogenetic train made by maximal likelihood method. So here is our input train. It's a little bit small, but you can still see here it's in the same clade with Telencorhynchus agri with a support value of 0.99. It's very high. So from phylogenetic species concept, they're in the monophyletic clade. And we can say it's the same species with Telencorhynchus agri. By the way, this phylogenetic tree was also automatically saved in the result folder. So you can see the tree here and you can download it. Okay. Now we go to the second function for the tropical root knot nematode identification. Remember, as I said earlier, this group of species cannot be identified by ribosome genes because they are very similar. So now we are using a mitochondrial gene called NAD5. Similar with the standard identification, you can also get the primer and the condition PCR conditions in the help page. So now I copy and paste the sequence here and sublimate. Now you have a alignment result, and this result only displayed those important snaps position. And the first one is your input. If you feel it's hard to interpret, to check and compare, then just click. In this case, it's similar with the species Melodicaine enterobi. Okay. However, in some cases, even an 85 is not enough. For example, I paste another sequence here. If we submit and click the identification result, you will see something different. So in this case, our sequence is one of these 5 species. And an 85 sequence is not enough. We need to supply other sequence like CYTB. So if you have CYTB sequence, just copy here We will have another similar process again, and at the end, you will get the species identification result. Okay, now it's the third part. In this program, we also include the references database. Like what I said earlier, in the gene bank database, there's many mistakes, errors. You cannot fully trust them. So here, all the sequences are manually checked, and I will try to upload at least twice a year to include the new sequence that has been published. So you can choose a different genes, different family group, and yes, you have a species here, of course, and just click search. You can copy this sequence and use in any purpose. Another way to use the database is to go to the file, and there's file like database. These are all the database that we have. And if you want to make a phylogenetic tree with like other method Bayesian or maximal likelihood, you can just take this sequence. It can be opened with Notepad and put your sequence inside and make your own tree by other phylogenetic programs. Okay, and in the last, you have a help for the general information about these programs. So yes, that's it. And before I finish, I want also to mention something about troubleshooting. Many people told me that they have some problem to install this program. For example, after they try to open this program, it comes out the error page like this. It tells application path should not contain blank. Please rename the folder name, then try again. So usually it means there's a space in the path or address. So like this one, the first one has a space. It's it's a problem. It's incorrect. And the second one is correct. Without space is correct. Okay. Sometimes we will also say that encounter the problem like this: unexpected gaps or mutation sites in the barcoding sites. It usually means your sequence quality is not good. So make sure go to check your row sequence and make sure the quality is okay. The second, um, it's also very common that your sequence is reversed and complement. So just reverse and complement them. There's on line 2 here. Okay, so if you have further question or comments, suggestions, you're very welcome to contact with me.